Good day, ma'am. My name is Redden Faith R. Brahami, and this is the assigned topic that I am going to discuss in this presentation. I'm going to explain various light phenomena such as halos, sundogs, primary rainbows, secondary rainbows, and supernumerary bows. First, let's talk about light phenomena. What are light phenomena? So, these are any so light phenomena. These are any observable events that results from the interaction of light and matter. Common light optical phenomena are often due to the interaction of light from the sun and moon with the atmosphere, clouds, water, dust, and other particulates. Light is a form of electromagnetic radiation that interacts with matter in different ways, resulting in various observable phenomena. These phenomena can be observed in the natural environment, in the atmosphere, and in in the human-made objects. One of the most common examples of light or optical phenomena is the rainbow, which is a result of the interaction of light with water droplets in the atmosphere. When sunlight refracts and reflects through the water droplets, it separates into different spectral colors, creating a beautiful arch of colors in the sky. So, another example is the mirage, which is an optical illusion due to the refraction of light. When the air near the surface is hotter than the air higher up. So, ang kining mirage kay if ang air kay duol siya sa surface, so mas hotter siya kaysa sa babaw, higher up. The light is bent and creates a distorted image on the horizon. A similar phenomenon can be observed when light is refracted through glass or water, creating a magnified or distorted image. In conclusion, as I conclude, the interaction of light with matters can result in a range of observable phenomena, from the natural beauty of a rainbow to the optical illusions of a mirage. These phenomena are essential to our understanding of the physical world and the properties of light. Let's proceed to our main topic. Let's proceed to the halos. Halos comes from the word halo, which is also called gloriole, icebrow, or nimbus. It is a light phenomena that happens when light shines through clouds that are composed of ice crystals. Light refracts upon passing through the ice crystal and also reflects upon hitting the crystal's faces. These events cause the formation of the bright ring around the sun and moon. Halo is usually bright white ring. So ang halo kay usually puti na siya nga kayong ring. But may also have colors due to the dispersion of light upon striking the ice crystal. Ma-form ang halos when sunlight or moonlight passes through the clouds that contain ice crystals. The crystal acts as prisms, refracting the light and splitting it into its various colors. The light is also reflected off the surfaces of the ice crystals, contributing to the formation of the halo. So the angle of the halo at which the light is refracted and reflected determine the size and shape of the halo. So, halo are often seen in cold climates. So, ang halo kay makita nato na siya if ting bugnaw ang ato ang panahon. Or when there are high altitude clouds composed of ice crystals, such as cirrus clouds. They can also be seen in the other environmental conditions, such as in the presence of contrails from airplane or around artificial light sources parehaan ng sa street light. So makita po natong halo kay sa sa like airplanes or around artificial light sources like street lights. So now let's proceed to the sundogs. So sundogs happen due to the refraction of the light upon hitting the small crystals that make up cirrus or cirrostratus clouds. These crystals are hexagonal in shape. So kini nga crystal kay yang shape niya kay hexagon and with faces almost horizontal upon drifting. This caused the formation on spots of lights or sundogs in either side of the sun or moon when light strike them at a maximum angle of 22 degrees. Since red light is less refracted compared to the blue, this makes the inner edge of the sundog to be red hood. So these crystals are hexagonal. So as they mentioned, these crystals are hexagonal in shape, and when light passes through them at a certain angle, it is refracted or bent, causing the light to spread out and form a halo or sundog. The maximum angle of refraction is around 22 degrees, which is why the sundog is always located at the distance of the sun. So muna siya nga, ang sundog kay dapit jud siya sa sun. The color of the sundog, or in some cases, the halo around the sun or moon, are formed by the different wavelengths of light being refracted at different angles because red nga light kay naa siya longer wavelength and it is refracted less kaysa kumpara sa blue light nga nag-appears lang siya sa sulod sa edge sa sundog, while ang blue light kay appears on the outer edge. Sundogs are a beautiful and fascinating natural phenomenon to observe. So, ang sundogs ang pinaka nindot o artificial na natural phenomenon nga imong ma-obserbahan and can be seen in many different parts of the world. Bisan asa nimo makita ang sundogs around the world. So, muna siya ang sundogs. So, unlike halo, now, bright ring, long shot on the sun, and sundog is not shy spot on either side of the sun. Meron siya kalahian niya sa halo. Halo. And next, let's proceed to the primary rainbow. And now, let's talk about rainbow. So first, I'm going to discuss what is a rainbow. So, I know and you know na familiar medyo ta unsa ng rainbow. So that is distinguished from other rainbows by its angular radius, colors, color order and brightness. So, ang rainbow kay nagkuha na siya sa iyahang color order o sa iyahang brightness. So, a rainbow is the light phenomena formed from the combination of several light properties. So, ang rainbow di ay, bantog na matingala ta, if mag-ulan na asya'y rainbow. Kay tungod sa mga several light properties ka mahitabo. Like, for example, kay refraction, reflection, and dispersion. Rainbows are usually seen after rainfall. So, di ba? Makakita naman taog rainbow if mag-ulan, if paghuman sa ulan, because they are formed when light strikes the scattered raindrops in the atmosphere. So ma-form ang ma-form ang rainbow kay because kung ang kahayag kay strikes the scattered raindrops, kung ang light kay maigo siya sa katong raindrops nga nag-scattered sa atmosphere. So, magka-create siya og kanang brightness and then ma-create ihang colors. So, wala siya ang rainbow. And next, the primary rainbow forms between about 40% 40 degree from the anti-solar point. The light path involves refraction and a single reflection inside the water droplets if the droplets of water are large, 1 millimeter or more in diameter. Red, green, and violet are bright, but there is a little blue. So ano siya? So the size of the water droplets can have an effect on the brightness of the colors of the rainbow. When the droplets are 1 millimeter or larger in diameter, so muna to siya ang red nga color, the green and violet colors of the rainbow are bright. But the blue is less visible because the blue light is scattered more strongly by the small droplets, making it appear brighter in the sky but less visible in the rainbow itself. So, ano matingalan ta nganong ang blue light kay kuan man siya less visible man siya kanang dili ka siya makita sa rainbow. It is because ang droplets sa rainfalls kay nag-scatter siya o maayo. Muna siya nga di kay siya makita. Less visible siya sa rainbow itself. So, it's worth noting that the size of the water droplets in the atmosphere can vary, which can affect the appearance of the rainbow. Multiple reflections and refractions can also lead to the formation of secondary rainbow and other optical phenomena. So, that is the primary rainbow. Now, let's proceed to the secondary rainbow. So, unlike primary rainbow, secondary rainbow has its color reversed. So, kabaliktaran siya sa primary rainbow. And also, sa secondary rainbow, mas bigger siya kaysa kay primary rainbow. So, the secondary rainbow is about 10 degree further out from the anti-solar point, that the primary bow is about twice as wide, as has its colors reversed. So, ang secondary rainbow is siya ma-form when light being refracted and reflected twice within the water droplets. This results in a fainter and wider second bow being formed. Since ang light niya kay being kay na reflected siya kaduha. So the order of colors get reversed. So ang color niya kay magka bali-bali, resulting in the red being located at the inner part of the bow and violet on the outer part. So it is true that higher order rainbows, which results from multiple internal reflections, are much weaker and hence are rarely observed. But when all the conditions are just right, you can sometimes see third and fourth order rainbows. These higher order rainbows appear very faint and are much wider than primary and secondary rainbows. So occasionally, a secondary bow may be observed, which is considerable less than the primary bow and has its color sequence reversed. The secondary rainbow has an angular radius of about 50 degrees and hence is seen outside of the primary bow. This is how results from light that has undergone two internal reflections within the water drop. Higher order rainbows are resulting from three or more internal reflections are exceedingly weak and hence are rarely observed. So, as I mentioned, it is true that higher order rainbows show results more for internal reflections. And now let's proceed to the next topic, which is the supernumerary bows. So, supernumerary bows, these are rainbows bordered by narrow colored bows like green, violet, or orange due to interference of light waves. They occur inside the primary rainbow or on rare occasions outside the secondary rainbow. So, ang supernumerary rainbow, ma-form siya by the light waves. If ang light waves mag-interact siya each other as they pass through the water droplets. So, mag-interact na siya sa through passing the water droplets. The waves interfere constructively and destructively, causing the light to reinforce and cancel itself out in certain areas. This creates the distinctive colored bands that you can see within or outside the main rainbow. So, kining a rainbow are not always visible as they require very precise condition to form. They are most commonly seen when the water droplets are very uniformly sized, typically between 0.1 and 0.3 millimeters in diameter. In addition, the observer must be positioned at the right angle to see the rainbow. So, kinahanglan, kung ang naiisak observer, kay gusto siya makita sa supernumerary bows, kay kinahanglan siya nga ayang position kay na siya sa right angle para makita niya ang supernumerary rainbow. Which is why supernumerary rainbows are seen less. Di kay siya makita frequently than primary and secondary rainbows. So, muna siya ang supernumerary bows. Now, let's proceed. So, how do light phenomena such as halo, sundogs, primary rainbow, and other supernumerary bows occur? So, they form as a result of how waves of land interact with small water droplets, unlike the primary and secondary bows that results from refraction and reflection of light inside larger raindrops. They more pronounced, it seems, when the drops are similar in size, ranging from approximately 0.5 millimeter to 0.7 millimeter in diameter. So, in the case of supernumerary bow or rainbows, the interference of light waves that we discussed earlier causes the wave amplitudes to reinforce and cancel each other out in a periodic pattern. This results in the narrow, colored bands that are visible within or outside the main rainbow. So, the phenomenon is more pronounced when water droplets are similar in size. So, mas kuan siya, ato pa siyang makita if or ma-pronounce if ang water droplets niya kay pare-pareha og mga sizes ranging from approximately 0.5 millimeter to 0.7 millimeter in diameter. This is tungod kay the wave interference effect are strongest. So, when the light waves are scattered at similar angles, so mas kusog ang iyahang effect kung pare-pareha ang sizes sa mga droplets sa water. Are scattered at similar angles, which occurs when the water droplets are similar in size. So, muna siya other light phenomenon. Now, let's proceed to what are the similarities and difference of halo and sundog. So, na-discuss na nato to siya kaganina kung unsa iyang kalahian. Now, so sundogs are rarer formations which there are two bright spots on either side of the sun or moon, much more rarely. Like a lens flare effect on a camera, sun or moon halos are simply giant bright circles around either the sun or the moon. So, sun or moon halos, on the other hand, are bright circles that can be seen around either the sun or the moon. So, these halos are also caused by the refraction of light through ice crystals in the atmosphere. So, the ice crystals act like tiny prism, bending and refracting the incoming light, which causes the halo to form. Both sundogs and halos are, So both halos and sundogs are beautiful and fascinating natural phenomena that can be observed under certain atmospheric conditions. So, di ba, as you remember, ang nalito kay sundogs is the beautiful and fascinating. But both halo and sundogs are beautiful and fascinating natural phenomenon na ito ang ma-observe sa atmospheric conditions. Next is, how will you explain the difference of halo and sundogs according to its light form? So, dali na punta. Ang ilahang kalahian, basta sa light formation nila kay 22-degree halos are formed when light passing through an ice crystals. So, ang halo, kay 22 degree na siya, formed kung ang light niya kay pass or moagi sa ice crystals, bends 22 degrees, while 46-degree halos occur when the light bends 46 degrees. Ice crystals in the atmosphere creates glowing spots on both sides of the sun called sundogs. So, muna siya ang iyahang kalahian sa halo ug sundogs kung mag-mention ta sa ilahang light formation. Now, let's proceed to why are primary and secondary rainbows have opposite arrangement of colors? Explain your answer. So, as this reflected light leaves the droplet, it is again refracted. A secondary rainbow is caused by a double reflection of sunlight inside the droplet. So the inside of the secondary is up to the observer and its color appear reversed compared to the primary. So muna siya. The color of the secondary rainbow are reversed. So, di ba, as I mentioned earlier, ang color dito sa secondary rainbow is reversed dito siya compared to the primary rainbow, with red on the innermost edge and blue on the outermost edge. This is because ang light niya kay nag-reflect siya kaduha instead of once. Siya nag-cause siya wavelengths para ma-separate ang colors. So, secondary rainbows are much dimmer than primary rainbows and are often harder to see. So, di ba? Ang secondary rainbow kay mas lisod siya makita, harder to see kaysa sa primary rainbows. They also have a wider arc, with the center point of the secondary rainbow being higher than that of the primary. As I mentioned, this is because the light is refracted at a different angle inside the raindrop. So, next is how does primary rainbow, secondary rainbow, and supernumerary bows differ? So, notice the well-defined supernumerary bows just inside the primary rainbow or lower bow, whereas the primary and secondary bows are produced by refraction and reflection. Supernumerary bows results from the process of diffraction. So, ang diffraction kay occurs when light waves bend around. So, so ang diffraction kay nagikan na siya sa light waves nga nagbend around sharp edge of obstacles, like the edge of the raindrops. So this causes the wavelengths of different colors to interfere with one another, creating the alternating bands of light and dark fringes that are characteristic of supernumerary bows. So, supernumerary bows can be difficult to see. Although difficult makita ang supernumerary bows, but they are often visible when the raindrops are small and uniform size. So makita siya kung ang iyahang sizes sa water droplet kay pari-pariha. They are beautiful and fascinating example of the complex physics behind the creation of rainbow. Next is and then let's proceed to the key points. So halos are light phenomena, which are formed when light passes through clouds and strikes the ice crystals in them. Na-discuss natin ang niya sa din nakabalikon. So halos are bright ring, which can be colored or just plain white light na ma-form siya around sun or sa moon. While ang sundogs are spots of light formed on either side of the sun or moon, which form light strikes the hexagonal ice crystal whose faces are aligned horizontally. So, due to the dispersion of light upon passing through the ice crystal, sundogs can be seen with red color inner edge, since red is the less refracted color. So, next is rainbow. Is usually after rain shower and with sun shining. So kabalo mo siya tanong ang rainbow makita na to if paghuman sa ulan. Then makita na dahil ang sidlak sa adamgos dahil nadra ang rainbow. And now next is the primary rainbow. It's formed when light hits a raindrop refracted and single reflection happens inside the raindrop. So next is secondary rainbows are formed when two inner reflections are done inside of one. This causes the several of colors in secondary rainbow in comparison to a primary rainbow. Last is the supernumerary rainbows. So are formed when light strikes small raindrops with almost the same size. These are bands of green, pink, and orange colors found inside the primary rainbows. So that's the end of our discussion for today, and I hope you have learned from my topic, and thank you for listening.